So first of all, my usual question, how many of you have never been to a science cafe before? Raise your hand. Been? Okay, well then I get to do my whole spiel. All right, okay. So Science Cafe, actually we have some history thanks to this man of Science Cafe, but I won't go into that. We'll go into that later. All right, our Science Cafe in New Hampshire started 7.5 years ago. A couple of science fans who knew that this was happening elsewhere thought it'd be cool in New Hampshire. They contacted me to help. We got it going first here, we went down to Nashua, now we do both Nashua and Concord every month, take the summer off. Since then, one has started in Manchester. It's run by Sea Science Museum. There was one last year, and I think they're restarting it up again in this fall out in Portsmouth. That's run at one of the brew pubs there. Dartmouth sometimes does one. So I say with no exaggeration, New Hampshire is the science cafe capital of the country in a per capita point of view. So you are part of a movement. It's really simple. Every month we think of a topic, invite a couple of panelists, 2 or 3, on rare occasions only 1, to talk about it. And the whole point of this is to answer questions. And so it depends on you guys asking stuff to keep things going, or else we'll have an awkward silence. Although I believe this man will be able to fill awkward silences. He does that very well. So, couple quick points to make. Nashua's Science Cafe is the 12th, next Wednesday. It's about STEM, science, technology, engineering, mathematics, and education. We will not have a Concord Science Cafe next month. I'm out of the country and there's nobody else to fill in, so I'm just skipping it. In November we're going to do one talking about space exploration. ConcordTV is filming this as it does every month, and we'll be putting it on their website and distributing it to television stations around the country. I guess we're extremely popular in Utah for some reason. So you get to see yourself if you're captured by the camera. You get to be able to see yourself on the web. Tipping. This is a non-trivial place for the wait staff to work, and particularly when we're this crowded, and particularly when it's so hard to hire wait staff as it is in New Hampshire right now. So I expect everybody here to be able to calculate at least a 20 and probably a 25% tip in their heads, because this is Science Cafe. So, but tip generously because they're really earning it tonight. And that being said, we're gonna go into it here. So I will start off by introducing. This is an unusual. This is a first of its kind Science Cafe. Usually we have a couple of people to talk about the topic, but today we're having this honorable gentleman here to talk about something that he personally has done that I suspect many of us know about. Let me ask, actually, how many have been to the Ig Nobel Awards down at Harvard? Anybody? Just a couple? How many are familiar with what the Ig Nobel Awards are? Okay, pretty good. All right. Okay. Well, he will talk about how they came to be, and then we will ask him questions about it, and he will no doubt entertain us. So let me hand this over to you. You can introduce yourself, and oh, actually, you're going to use your own microphone. You can introduce yourself, and we'll go from there.
Okay. Hi. My name is Mark Abrams. I'm the editor of a magazine. This magazine is called the Annals of Improbable Research, which this is the paper version, but we gave up paper 2 years ago. It exists now as PDFs. It's all electronic and very inexpensive to subscribe to also. And it grew out of an earlier publication that I became the editor of sort of by accident. The earlier magazine was called the Journal of Irreproducible Results, which maybe a few of you know. Started in the mid-1950s. It had a long, truly crazy history, and in 1990, I had never seen the thing, but somebody had told me that they might want to publish some stuff I'd written, and I had never tried to get anything published anywhere. I just, since I was a kid, gathered odd things and wrote them and gave those to friends, but I decided to give it a try. And I sent some articles off to this magazine, which I wasn't even sure that it existed. All I could find was an address. I couldn't even find the magazine, but I sent some articles off. And a few weeks later, I came home from work. I had a little software company at that time. And there was a message on my phone answering machine from a man who said, "Hello, I'm the publisher of the journal. I got your articles. Would you be the editor of the journal?" So this was my introduction to the world of science publishing. And I got together with him, and I couldn't not do that. So for about 4 years, I had a double life, running my little software company and bringing this magazine back to life, because it had really been kind of killed off. And got the original scientists and a lot of other people involved, and I thought we should have some kind of event, but also it was kind of clear to me what kind of event we should have. Because when I became the editor of a magazine, having very little background about how you edit a magazine, I decided, well, I've got a license to call anybody in the universe and ask them for advice. And I did, and it was great, and people were great. I mean, including a lot of really famous people who were just wonderful about giving advice, and a lot of it even was good advice. Some of it wasn't. And I was also meeting lots of people I would interview for the magazine. The magazine has the same flavor as the current one, that it's all about things that make people laugh and then think. And I kept running into people, and people from around the world, who had done all kinds of bizarre things that were so just outside my experience and outside anybody's experience, that your only reaction when you first saw these things was you would laugh. You know, you didn't even know whether you liked it or you hated it or you thought it was great or bad. It was just, it made you laugh because it was so outside your experience. And then there was something about it that would stick in your head, and you'd find a few days later you still want to talk about it. You want to tell your friends about it. You don't want to do your work. You want to tell your friends about this thing. And that's the quality that we've always looked for in these things. And as I was meeting people who'd done these kinds of things, I kept thinking, nobody in the world hardly knows that these people exist, or that they did these things. And most of them are going to go their whole lives, and they're going to die, and nobody will ever know they did this. And that's wrong. Somebody should do something. I thought, well, we can do something small. So that was the idea behind the Ig Nobel ceremony, that we would pick a few people who've done these things, invite them to come wherever the thing was going to be, whatever the thing was that we were going to do, and see what happens when you get them in a room with some people. And we did that, and as I went around asking people for advice about how we could do stuff like this, people started offering help on that, including things like somebody introduced me to the head of a museum at MIT who invited me over, and I told him about my plans, and he said, well, do you have a place to have this? No. Do you want to have it here? Okay. And I had a just almost unbelievable run of about 6 months at the start of the magazine, where almost everything that I started just worked out wonderfully. Just dumb luck, and a lot of help from a lot of nice people. And so that first year, 1991, a bunch of us, it was me, a bunch of other editors, a bunch of scientists, a bunch of journalists, and by that time I knew a lot of people around the world, so it was people from all over. We picked 10 of these things and invited a few of them to come. It didn't even occur to us that most of them might come if we invited them, so we only invited a few. I had met a whole bunch of famous scientists, so I invited 4 Nobel Prize winners to come to this thing, and they all said, sure. And I said, well, you might want to dress up in some unusual way, funny hat or something. And they all said, okay, and they did. And we put notices out on the internet, which back in 1991 was much smaller than it is now, and was a lot more populated by just academics. And we said the first annual Ig Nobel Prize ceremony will be held at MIT in the museum on such and such date. And this year the tickets are free, but you need a ticket, and the tickets are going to become available Tuesday afternoon, September whatever, at this office at MIT. that date came, and hundreds of people showed up, and the tickets all vanished instantly. And the night of the thing came, we had more people trying to get in the building than the building would hold. We had people who were almost crawling up the sides of the building trying to get in. Had a couple of winners, we had a bunch of famous scientists, we had reporters from around the world for some reason, and lots of people, and we had a good time, and the whole night I had the feeling, and looking around at everybody else, I'm quite sure everybody else there, including all these famous scientists, had the same feeling, which was at any moment some grown-up person is going to come up and tell us to stop this and go home. But nobody did, and we had a very good time. And the next day, reports started appearing in the news around the world, because Reuters and Associated Press, I think, and a bunch of other wire services, as well as a lot of the big science magazines and newspapers and radio and stuff, were all covering this thing. And over the next few months, there were reports all around the world about the Ig Nobel Prize and the Ig Nobel Prize ceremony. So this was great, and we decided we should really think about what we're doing and what parts of it worked, and are there some parts that didn't. And the next year we decided, okay, well, we can do this on a bigger scale. And we were in fact forced to, because the MIT, I'm giving you a lot more detail here than I usually go into, but we're stuck here for 2 hours, so. But I have lots of other stuff I'd like to tell you about and ask you about.
All right, questions from the audience? I have one right here.
Okay. Are there certain branches of science that are more likely to be nominated for the award?
Oh boy.
And are some underrepresented that probably should deserve more attention?
There are lots underrepresented. Well, first of all, the prizes are not all for science. They can be for anything. We've given prizes for all sorts of stuff, but a lot of them are about science. There are lots of fields that are underrepresented because there are lots of fields. And most fields are so specific that almost nobody outside those fields has even heard of them. And there's all kinds of stuff on the table in front of you that even the manufacturing process involves all kinds of scientific discoveries that you're not aware of and I'm not aware of. But the glass would not be shaped the way it is without people having made a lot of discoveries. The stuff that we were drinking here, the shapes of the table, all sorts of things. You may yourself do something for work that seems really so obscure to other people that you're embarrassed to even get in conversation, because you know they're embarrassed because they don't understand. Or maybe you have relatives or friends who do things where what they do is perfectly wonderful and sensible once you get a little explanation, but it might take 10 or 20 minutes of explanation before anybody thinks that this is something other than just craziness. There's lots of stuff like that. And those make wonderful Ig Nobel Prizes because they're so surprising to people.
All right. I can actually have a sort of a secondary question to yours.
Yeah.
Which are there topics that you've given so many Ig Nobel Prizes to that they've sort of been worn out and you don't want to go back there again?
Boy, I need to think about that. When we give a prize, we try not to give one that's going to be similar to something we've done before, unless it clearly builds on that and turns it upside down or tops it or something like that. There have been a few things like that. And there have even been a small number of cases where the same group of people or the same individual has won more than one Ig Nobel Prize. Let's see, one of the sequences, about, again, maybe 10 years ago, we gave a prize to a couple of physics people in California who had done some experiments to, may I borrow your glass? Not quite with this shape of glass, but they looked at the physics of what happens when you have a full cup of coffee and you hold it out like this and you walk across a room. Probably just about everybody here has done that, and what happens most of the time is you spill it. And they wondered, why exactly is that? What's the physics here? Is it mostly because people are clumsy, or is it something else? And what they found is that, well, if you're clumsy, you're going to spill anything, but no matter how graceful you are, you're almost certainly going to spill the coffee quite often, because the physics forces you to. And part of what's going on there is that when you're walking just a natural gait, you get into rhythm. You don't even think about it, but you're walking in a nice rhythm. And whatever you're holding gets in a rhythm. And it sloshes if it's inside a coffee cup. It won't do it quite so much inside these wine glasses because they're shaped at the top to kind of contain that. But the coffee cups, when they're full, there's nothing to contain it. And it's going to slosh and it's going to spill. We gave them a prize, and we had some nice demonstrations. That's a really nice, easy one to demonstrate. A year ago or 2 years ago, I forget which now, I think it was last year, we gave a prize for something similar to a kid who, let's see, by last year he was a college student in the US, but he, a couple years earlier than that, had been a high school student in South Korea. And he read news reports about this Ig Nobel Prize for this spilling on the cup of coffee, and he got really fascinated. He read up on it, and he did some experiments, and he ended up going really deeply into the physics of it, and he wrote and published a physics paper, a really detailed one, about what happens when you hold a cup of coffee like that, full cup of coffee, and walk backwards. What's the physics? Is it the same? You know, has anybody here tried it? Would anyone here like to try it? There's nothing stopping us if somebody can get a coffee cup. Well, if somebody wants to arrange that, we can do that at any point. What he discovered was it's different. That you're not as likely to spill coffee, at least not for the reason you think. Because most people are not good at walking backwards. You know, maybe an extremely highly trained dancer is good and will get into a rhythm, but most people won't. It's herky-jerky when you walk backwards, when I walk backwards. And so because you don't get into a rhythm, the liquid doesn't slosh the same way, and it doesn't resonate, and it doesn't spill. At least it's not as likely to. However, walking backwards holding a full cup of hot coffee is maybe not a good idea. You might trip and spill, you might crash into something. He did the mathematics of it, and the physics of it led him to discover something else, though, that there was at least one other way he discovered that makes it pretty stable, even more stable, when you're walking backwards. And it's what he calls the claw hand method. If you've got a glass, you put your hand over from the top and hold it. The difficulty for that is if what you're holding is a full hot cup of coffee, well, all right. Independent of that, there's a lot, for the magazine, I look up a lot of all kinds of stuff, and people send us stuff. Most of the people we know about, we know because people everywhere send us stuff. It's great. Every day we get this beautiful flood of things, you know, seemingly obscure. There are all kinds of research experiments people have done over the years for lots of different reasons involving liquids, and some of them involve coffee. And there are some, I think some of them were done in Italy, some not so long ago, about that showed that if you have a latte, if you have coffee with a lot of foam, milk foam or any other foam, but generally milk, that foam is going to damp down the sloshing. And that foam is going to, and other experiments show, does at least two things. One is it's going to keep it from sloshing so much. So if you're carrying a full cup of latte with lots of foam, it's not going to spill as easily as if you're carrying a full cup of black coffee. And the other thing is that latte insulates the temperature a little bit. So it's going to keep your, the drink part of your drink warmer for a little longer than the thing would if it were just liquid. And so all these things, once you read these, if you go and read even one of these studies, even though most of them are difficult to read because they're written in this really obscure language because people feel they have to, for professional reasons, impress each other with this crazy, stupid, hard-to-read language. But you can wade through a lot of these things, and you can get the gist of them. And down at the end of them, often there's a list of things that they got some of their facts from. And sometimes what's down in those lists is even more interesting. So we try when we can to glance through the lists. And sometimes that'll take you off in some direction you never dreamed of. That's far, far more interesting than anything you were doing.
Sort of like Wikipedia, you click on things. All right, I have a question here.
Yeah, actually, sort of two questions. First, do you tend to avoid giving prizes where some prior prize has already been given? And second, are there any examples where a subsequent prize has been given?
Yeah, we don't try to avoid, if it's gotten lots of prizes or lots of anything, that's fine as far as we're concerned. This is completely independent of everything else. Some of the things have gotten all kinds of prizes, not a lot, but some of them have gotten prizes in their fields because some of them are really extraordinary science, and some, in fact, have led to a lot of money and things. But there's one case that a lot of people like to talk about, and we find it pleasing. We gave a physics prize in the year 2000 to a couple of scientists in Britain. Well, one of them was in the Netherlands at the time. It was the physics prize, and it was because they used magnets to levitate a frog. Before they did that, nobody thought you could do anything like use magnets to levitate a frog. You can also levitate water, or almost anything, in fact. And once they realized they could do this, they wrote some physics papers, partly because they realized almost no other physicist believes this is possible. So 10 years after we gave them that Ig Nobel Prize, one of them was given a Nobel Prize in physics. Not for the same thing, but for something that sounds equally goofy. Right. The way it's generally discussed in public does not sound goofy. It's because he and one of his students got the first usable amounts of a substance called graphene. It's a form of carbon that for a long time chemists knew this form of carbon existed. It's two-dimensional. It's like the way the molecules hang onto each other. It's the shape of chicken wire. It's one molecule thick, and they're pretty sure it's really strong and probably does all kinds of interesting things, but it kind of drove chemists crazy up until these people discovered what they discovered, because nobody could get any of it. They knew where it was. It's everywhere. In your pencil, if you have a pencil, you've got some graphene. The gray part is called not graphene, but what? Graphite. And that graphite is really layers, millions of layers of this graphene that stick together. You know, these layers are one atom thick, and they stick together so tightly, nobody anywhere had managed to pry them apart and get enough of it that they could look at it under a microscope or any other way and find out anything about how it behaves. And then one night, kind of fooling around, because this physics professor has a habit with his students of Friday nights, let's just try stuff that seems kind of nuts and quietly. And that's how the frog thing happened, and that's how this other thing happened. And they were fooling around, and they did what almost every kid does. They took a pencil, and they just scribbled on a piece of paper, and then they took the paper, and you fold it, and you flex it back and forth, and little bits of dust come down. They took some of those little bits, and they stuck it under a microscope, and they discovered some of those little bits, it's graphene. They had the first bits of graphene that any scientist looked at. And once they realized what they had, they started making all kinds of discoveries. And now, some of you, I probably know far more than I do, but some of you may not have run across it. If you go and Google the word graphene, there are industries, hundreds of industries around the world that are built on this, and hundreds and thousands of existing industries that are pretty convinced that this stuff is going to be like silicon was. It's going to be used in all kinds of things and change all kinds of stuff, because it's got all kinds of useful properties they're just starting to find.